So welcome everyone to our last topic for our last chapter in statistics. So your perseverance got you here. So our last topic for this chapter, which is also the last, it's regression analysis under chapter 6, correlation and regression analysis. So we have four main objectives. For today, it is to identify the independent and dependent variables, calculate the slope and y-intercept of the regression line, interpret the calculated slope and y-intercept of the regression line, and to predict the value of the dependent variable given the value of the independent variable. Suppose you are the CEO of Manga Company. So Manga Company is a Filipino-based company which is selling technological devices. Laptops, desktops, smartwatches, smartphones, earphones, and others. You are trying to predict the next month's numbers. Here are some of the variables that we can look at. The competitor's promotion, number of devices exploding, the standing of the country, pandemic news. So why don't you list down on your modules some of the variables that you can think of that will affect your next month's numbers? In statistics, there is a way to mathematically sort out which of the identified variables I have here and also which of the identified variables that you have there do have an impact. It is called the regression analysis. So regression analysis, it is a statistical method used to determine the strength and characteristics of the relationship between a dependent variable and a series of other variables. This analysis is used to predict the value of the dependence variable based on the known values of the independent variable. If we want to see the strength and direction, the relationship between more than two data, we're going to use regression analysis. For example, in an industrial situation, it may be known that the tar content in the outlet stream in a chemical process is related to the inlet temperature. It may be of interest to develop a method of prediction, that is, a procedure for estimating the tar content for various levels of the inlet temperature from experimental information. Now, of course, it is highly likely that for many examples runs in which inlet temperature is the same, say the outlet tar content will not be the same. This is much like what happens when we study several automobiles with the same engine volume. They will not all have the same gas mileage. So, ibig sabihin, meron kasing way to predict, okay? So, gagamit ka ng experiment, di ba? So, hindi porket pare-pareho ng volume of gas ang nilagay mo sa bawat kotse, pare-pareho na din ang gas mileage. Houses in the same part of the country that have the same square footage of living space will not all be sold for the same price. Kasi merong corner lot, merong middle lot, meron yung lot na malapit sa tricycle, merong lot na malapit sa highway. Tar content, gas mileage, and the price of houses are natural dependent variables, while inlet temperature, engine volume, and square feet of living space are natural independent variables. So I've been talking about independent and dependent variables. So just to recall, we have there the two types of variables, independent and dependent. When we say independent variables, these are variables that is controlled and assumed to have a direct effect on the dependent variable. When we say dependent variable, these are variables that are being tested and measured and is dependent on the independent variable. For example, ang independent variable mo is yung gaano katagal ka nag-aral para sa quiz mo in statistics and probability. Your dependent variable mo would be your score in the quiz of statistics and probability. So in order to conduct a regression analysis, data gathering should be first done. In the example, you take all of your monthly sales numbers dun sa Manga Company for the past 3 years and any data on the dependent variables you are interested in. In this case, let us say that you find out the average monthly sales of your rival company, Apple, for the past 3 years as well. Then, you plot all the information in a scatter plot diagram sketch that looks like this. The y-axis is the amount of sales, amount of your sales, dependent variable, and the x-axis is the amount of sales of your rival company, which is going to be your independent variable. Each point represents 1 month's data, the sales of the rival company and the sales of your company for that month. Now, imagine drawing a line through the sketch above, one that runs roughly through the middle of all the data points. This is called the regression line, and it is drawn to show the line that best fits the data, the line of best fit. In other words, the line is the best explanation of the relationship between the independent variables and dependent variables and can be represented in an equation. So this is the equation used for regression analysis. We have y is equal to mx plus b. A reasonable form of a relationship between the dependent and independent variables is the linear relationship where m is the slope and b is the y-intercept, and your x, your independent variable, y as your dependent variable. To recall, the slope of the line is the change in y over the change in x, where the y-intercept is the value on the y-axis where the line crosses or when the x is 0. So you have two examples there. Y is equal to 2x minus 6. Your slope for the first example is 2 from y is equal to mx plus b. And your y-intercept for the first example is negative 6. So you have there a positive slope. That means it's a line rising to the right. For the second example, we have y is equal to negative 2x minus 6. From y is equal to mx plus b, your slope there is negative 2. So you have a line rising to the left, and your y-intercept is negative 6. So the simple linear model is expressed using the following equation. Y, your dependent variable. A, your intercept in y. B is your slope. X is your independent variable. Simple linear regression lang tayo. We're not going to discuss multiple linear regression and non-linear regression. So simple linear regression is a model that assesses the relationship between a dependent variable and an independent variable. So how do we create a regression line? In creating the regression line, there are two things to compute for: the slope and the regression equation of x on y. Okay? In computing for the slope of the regression line, regression coefficient of independent variable on dependent variable, we use the formula b is equal to n, your sample size, multiplied to the summation of the product of xy minus the product of the summation of x and the summation of y all over n multiplied to the summation of the squares of your x minus the square of the summation of your x, where n is the sample size, x is the independent, y is the dependent variable. Next, for regression equation of x on y or regression equation of the independent variable on the dependent variable, we have the equation y minus the mean of y equals b, where your b is your slope, multiplied to x minus x bar, or the mean of x. Isolating y, we have y equals b multiplied to the difference of x and its mean plus the mean of y. So there is a shortcut, right? If the mean and the standard deviation is given, we can compute for the regression line by the following formulas. You have regression line of x on y and then regression line of y on x. Yung una, independent to dependent. Yung pangalawa, dependent to independent. So you have there the first one, x minus mean of x equals R. Your R is the value of your Pearson R from your correlation analysis, multiplied to the standard deviation of x divided by standard deviation of y, multiplied to the y minus the mean of y. Next, you have for the second line, y minus the mean of y equals R Pearson R from your correlation analysis multiplied to standard deviation of y divided by standard deviation of x multiplied again to x minus the mean of x. Kung mapapansin nyo, yung unang equation tsaka pangalawang equation, nagpapalit lang ang variables. Yung mga x nagiging y, yung mga y nagiging x. So take deep breaths. We are moving on to our examples. We're more than halfway finished through this lesson. Stretch. Oh, my back. So let's have the first example. We have here the time X in years that an employee spent at your manga company. And your employee's hourly pay, Y, for For the first one, you're going to compute for the slope. Remember these columns, x squared, y squared, and xy. X squared is just getting the square of your x. So 5 times 5 or 5 squared, that's 25. 3 times 3 squared minus the square of the summation of x. Okay. So we are computing for regression equation of x on y. So independent variable to dependent variable. So you have there b equals, hanapin nyo yung sample size nyo. Ilang employees ba kinuha? 5, di ba? So your sample size would be 5. So you have there 5 multiplied. What is the summation of xy? That's 1,189. So copy it, 1189. Minus, what's your summation of x? 37 times summation of y, 139. 84, 10 times 35, 350. And for the last one, you have 15 times 38, which is equal to 507. After getting the next 3 columns, which is x squared, y squared, and xy, get the summations of each. Summation of x. So, ibig sabihin, na-add nyo yung column sa x. 5 plus 3 plus 4 plus 10 plus 15, that's 37. Next, summation ng y equals 139. 20 ng y equals b. Yung kinumpute yung slope kanina, times 102 equivalent to 139. Do that also for the next summations. Summation of x squared, that is going to be 375. Summation of y squared, summation of and then list all your summations. Summation of x, summation of y. Y mo, that's going to be summation of y, which is 139 divided by 5 equals, yung slope na kinompute mo kanina, that's equals to 1.585 multiplied to x minus summation of x, that's 37 divided by n, 5. After that, copy your left-hand side. Next, it's going to be equals, distribute mo yung value na 1.585. Meaning, i-multiply mo sa bawat values ng second mo. That's going to be 1.585 times x minus 11.729, which will result to a given regression equation of y equals 1.585x plus 16.071. So you have there your regression equation, y equals 1.585x plus 16.071. For an employee who has worked for 17 years, what is his or her predicted salary per hour? So, kung meron tayong nag-employee na nag-work ng 17 years, your 17 years, it's your independent variable. So, it's the value of x. Diba? So, yung 17, isa-substitute mo lang yung value noon dun sa x sa regression line mo. That's going to be y equals 1.585 times 17 plus 16.071. The answer is going to be 5377 over 125, which is also equivalent to 43.016. So, itong employee na to na who has worked for 17 years in your company is paid hourly na 43.016 pesos. Let's have another example. Example number 2. There are 2 series of index numbers. P for price index and S for stock of the commodity. The mean and standard deviation of P are 108 and of S are 103 and 4 respectively. Ibig sabihin, yung mean ng P mo, 100, standard deviation ng P mo, 8. Mean ng S mo, 103, standard deviation ng S mo, 4. The correlation coefficient between the two series is 0.4. With this data, let's obtain the regression lines of P on S and S on P. So let's set X for price P and Y for stock S. So for the first one, the regression line of X on Y. If the mean, standard deviation, and the correlation coefficient is given, there is a way to compute for the regression line using these variables. Pero kung mean and standard dev lang ang given, of course, you have to compute first for your correlation value. So for the first one, so regression line of X on Y, you have X minus mean of X equals R, correlation value, multiplied to the fraction of standard deviation of X, standard deviation of Y, multiplied to the Y minus mean of Y. So from our given, we have X minus 100 equals 0.4 times 8 over 4, where your 8 is the standard deviation of P and 4 is the standard deviation of S, times Y minus 103, your mean of S. That's going to be equal to X minus 100 equals 0.8 times Y minus 103. Manipulating your variables, you're going to have the final answer of X equals 0.8Y plus 17.63. For the next one, we're going to have regression line of Y on X. So we have there Y minus the mean of Y equals R times, balik na rin, standard deviation of Y divided by standard deviation of X multiplied to X minus the mean of X. So from our given, we have there Y minus 103 equals 0.4 times 4 over 8. Standard deviation of Y, standard deviation ng S yon, 4. Over standard deviation ng X, standard deviation ng P, yon. So 8. Multiplied to X minus 100, where 100 is the mean of your P. After that, you have Y minus 103 equals 0.2 times X minus 100. Manipulating the variables in your equation, we are going to arrive at the final answer of Y equals 0.2X plus 83. So from example 2, here are your two regression equations. The first one, regression line of X on Y. So you have X equals 0.8Y plus 17.63. For the second one, you have regression line of Y on X. You have their Y equals 0.2X plus 83. Okay. So ma'am, from regression line of X on Y, pwede ko naman makompute na directly the equation of Y. So pwede kong gawing Y equals X minus 17.63 divided by 0.8. Bakit hindi na lang natin ginanon? There is a certain equation that we are using to compute for the regression values. If you're going to remember, yung standard deviation natin, pinagbaliktad. Yung factor na pinagbaliktad mo, yung standard deviation, would give you a different equation. So I have here two questions. So what is the price of an item having 200 stocks? Okay? So item, price of an item P, that's X. Having 200 stocks, S, that's yung Y, that's your dependent variable. So you have there your X equals 0.8 times 200, yung given number of stocks mo. Given your number of stocks, you're looking for the price, di ba? Plus 17.63. Next, we have X equals 160 plus 17.63. This would give us the value of X, 177.63. So, ibig sabihin, ang price ng item mo having 200 stocks is 177.63 pesos. Next, we have the second question. What is the number of stocks of an item having a price of 100 pesos? So, kung kanina, given yung stocks, given yung Y mo, hinahanap mo yung X. Ngayon naman, given yung X mo, given yung price, hinahanap mo ang Y, number of stocks. So, to compute for that, nawawala yung Y. Y equals 0.2x plus 83 ang gagamitin. So, Y equals 0.2 times, ano yung price na binigay? 100 plus 83. After that, you're going to have Y equals 20 from 0.2 times 100, that's 20, plus 83. That would give us an answer of Y equals 103. Ibig sabihin, pag ang price ng item mo ay 100 pesos, ang number of stocks mo ay 103. Summarizing our regression line, we have y equals a plus bx, where your a is your y-intercept, b is your slope, x is your independent variable, and y is your dependent variable. We have there on how to compute for the slope, how to compute for the regression equation of x on y. And then you have there the two shortcuts pag given ang mean and standard dev and the correlation value. So you have the regression line of x on y and the regression line of y on x. So that is it for your chapter 6 on lesson 3 on how to create your regression line given under regression analysis. So do not forget to post your output and thank you for watching.